Hello all, welcome to this session. In this session, I am going to answer one of the Java interview questions. That is, what is JIT or JIT compilation? Let me answer. JIT stands for just in time. Okay. JIT compilation means just in time compilation. Okay. So in most of the cases, they will be writing something like this, just hyphen in hyphen time. Okay. Just in time compilation. JIT compilation is same as just in time compilation. Okay. So where exactly it will come in picture in Java? I'll tell you. So JVM uses JIT compilation. Okay. JVM, we already know about JVM in Java, right? That JVM uses JIT compilation. Okay. For what purpose? Before getting there, let me give you some high-level summary of what's happening. Okay. So that you will get to understand what JVM is doing and all. Okay. With the help of JIT compilation. So for that to happen, let me draw something for you. So guys, we already know that. Let's say you have written some Java code here. Let's say this is a Java code. Using the Java programming language in one of the editor or whatever it is, you have written some Java code. Okay. So before running this particular Java code, what we have to do, guys, we have to compile this Java code. Okay. Using Java compiler, we have to compile this Java code. Okay. So Java code will be written in .java file. Once the Java compiler compiles this Java code, and if there are no mistakes or errors in this Java code, there is no compiler errors are there, then this Java compiler, after compiling, will convert this Java code in the .java file into bytecode. Okay. What will be created? A bytecode will be created. So Java code will be converted to bytecode after compilation. Java compiler will convert the Java code into the bytecode, and because of which process we'll get .class file. Okay, because of this process we'll get .class file. In the .class file, bytecode will be there converted. Okay, converted bytecode by Java compiler will be there in the .class file. Okay, till there everything is fine. Now this bytecode can be understood by, okay, this code can be given to any of the JVMs. Okay, we have different machines. Let's say this is a Windows machine, this is Mac machine, this is Linux machine. Every machine, uh, in this every machine, Java is already installed, guys. Okay, Java for Windows is installed here, Java for Mac is installed here, Java for Linux machine is installed. So when you install Java for Windows, JVM for Windows will be there in this particular machine. Okay, when you install Java for Mac, JVM, okay, which can understand the Mac machine will be there here. Okay. So when you install Java, which is specific to Linux, so JVM for Linux will be there in this machine. Okay. This bytecode can be understood by the JVM, right? What JVM will do? JVM has to convert this bytecode into the native machine level code. Okay, JVM has to convert this bytecode into the native machine level code. Okay, so native machine level code for this Windows machine. Okay, whereas this JVM of the Mac machine has to convert this bytecode into the native machine level code of this Mac machine that this Mac machine can understand. Okay, and JVM of this Linux machine can convert this bytecode into the native. Okay, will convert this bytecode into the native machine level code, which can be understood by the Linux machine. That's what happens. But how this conversion will happen? How the JVM will convert this bytecode into the native machine level code? JVM has its own interpreter, first of all. Okay, JVM interprets this code. Interprets. JVM interprets this bytecode step by step or line by line. Okay, JVM interprets this bytecode line by line, one by one line. It will interpret and convert this bytecode into the machine level code. Okay, this JVM also will do the same thing. It will convert. It will also have its own interpreter, and it will convert the bytecode line by line into the machine level code by interpreting line by line. This JVM also do the same thing, interpreting the bytecode into the native machine level code, which is related to the next machine, line by line. But this process will take a lot of time. Line by line interpretation or converting the bytecode into the native machine level code will take a lot of time. But why JVM will convert this bytecode into the machine level code? So that JVM can run it. Okay, without converting into the machine level code, JVM cannot run this particular code. Java code is generally run in the machines when this Java code gets converted to the machine level code. But for this to happen, first compiling should happen where Java code will be converted to bytecode. Bytecode JVM can understand why bytecode is converted here to make this platform independent, to make the Java platform independent, so that every respective JVMs of the respective operating system can understand this and run anywhere, write anywhere, run anywhere. For that, JVM is there. For that, bytecode conversion will happen, and JVM can understand this bytecode and will interpret or convert this bytecode into the native machine level code. But this conversion of bytecode into the native machine level code by JVM only by taking the help of interpretation, its default interpretation will take a lot of time. So JVM, what it will do is inside JVM only, there's one more thing known as JIT. Okay, JIT, just in time. We call that as just in time compilation. So what's the advantage of JVM having along with this interpretation of JVM, where interpretation of bytecode happens line by line conversion into the native machine level code. JVM also includes something known as JIT compilation, okay, which has the capability to convert the bytecode, okay, into the native machine level code dynamically. Here, dynamic conversion will happen. Dynamic conversion of the bytecode into the native machine level code will happen. How that will happen? So JIT compilation is very smart that it will find some hotspot kind of stuff where you see whenever you write some, it understands some kind of bytecode, okay, preset kind of bytecode. So whenever such kind of bytecode, out of all the bytecode, when similar kind of bytecode is observed according to the memory of the JIT compiler, right, that bytecode will automatically, dynamically get converted to the native machine level code. Okay, so no line by line. Here line by line will also be going on. Along with that, JIT compilation way of identifying some patterns in this bytecode, which can be easily or faster way of converting into native machine level code also will be there. Two-in-one kind of thing. Okay, JVM has two-in-one thing where line by line, if bytecode patterns are not identified, JVM will interpret that line by line into the native machine level code, which will take a lot of time. Okay, whereas JVM also use JIT compilation, which smartly identify the different patterns in this bytecode and try to convert that, try to compile them into the native machine level code, okay, in a faster way. So when these two things are combined in a strategical way, so automatically this bytecode will get converted to the native machine level code in a faster way, guys. Okay, only with interpretation it will take a lot of time, but interpretation and compilation, JIT compiler way of converting into the native machine level code will become faster, and because of which JVM will be able to run the Java programs in a faster way. Okay, so this is what is the thing, guys. Now understand the answer for this question I have given here. What is JIT compilation? First of all, JIT stands for JIT stands for just in time. That is just in time compilation. If in full form I have to speak, okay, it is one of the component in JVM, guys. Okay, in Java, Java JRE will be there. In JRE, JVM will be there. In JVM, okay, in JVM we have JIT compilation, like that. That is the process. Okay, JVM uses JIT compilation. Okay, JVM uses JIT compilation in addition to its step-by-step interpretation process of converting the bytecode into the native machine level code for execution of the code. Okay, JVM along with its step-by-step interpretation process of converting the bytecode into the native machine level language code. Okay, it also uses takes the help of the JIT compilation, which is part of JVM. Okay, to identify the patterns in the bytecode, which can be converted dynamically into the native machine level code, so that the process of converting the bytecode into the native machine level code will speed up, and because of which the execution will happen faster by this JVM. Okay, so hope guys you got the answer for this question. So that's all for this session. Thank you. Bye bye.